Hello, friends. Welcome back. Here we are, back in ComfyUI, back on YouTube, back on creative exploration. Hope everybody's doing well today. Been a bit of a crazy day, but here we are. So yeah, last time we were here, we went through how to make images and how to set up ComfyUI, how to do diffusion in general, all that sort of stuff. And today we're going to take it a step further by going from still images to animations. This is meant to be a very beginner type of situation, so feel free to tune out if you already know this stuff. This is just to go over all the foundations so that you have a good idea of what you're getting into when you start looking at these notebooks, so that when we do more advanced streams, yeah, there won't be an issue. You'll be able to go back to these ones and see what you need to see and learn what you need to learn to make things happen. So let's clear this all up, get rid of all that. So I want to just talk first about animation basics. With images, I mean, we're just making a single image, right? But with animations, we're making a sequence of images. So everything you do is multiplied by however many frames you're doing, right? So obviously, video and animation takes longer than images because instead of generating one frame, you're generating like 24 or 48 or 480 or 4,000 in batches. I'm going to talk about basically like how batches work in ComfyUI, the concept behind AnimateDiff and how it animates in relation to how you can think about time and like how long your animations are, stuff like that. So we're going to go right from the very sort of very most bare bones AnimateDiff setup. We're going to add ControlNet to do masking. We're going to add IPAdapter to do even more masking, and we're going to add I don't know, maybe some other fun stuff down the road. So, but yeah, we're just going to start out with just simple stuff to begin with. So like I said, last 2 days ago, we made an image. We learned what LoRAs are. We learned what checkpoints are. We learned what all that stuff is. All that stuff that we learned last week is applicable to this stuff because we're not just making one image, we're making multiple images with the same setups, basically. So yeah, let's get started. Let's do a very simple AnimateDiff setup. So we'll load a checkpoint. Let's load checkpoint loader. We're going to choose, just for easiness, I'm going to choose an LCM checkpoint. I don't think I even covered LCM last week, so maybe I'll talk about LCM a little bit today. LCMs are distilled models. They get to the result much faster, sometimes half as many steps. So sometimes people will find that the LCM stuff is a little flat, but it's fine. I use LCM pretty much exclusively now because of the speed. So you can get great stuff out of it, and I'll talk about a few tricks about how to use it. But yeah, we'll be using LCM for these animations because, again, it's about twice as fast as doing it normally. And then that number goes up when you go up in res. So yeah, LCM is great. The model I'm using today is called Realism by Stable Yogi, and it is on Civitai. I linked to that last week, but just civitai.com. Yep. And it's the link there, and just search for Stable Yogi, Realism by Stable Yogi. All right, and we're going to add a LoRa. We don't actually need this LoRa when we're using the LCM checkpoint, but I'm going to add it anyway. And I'm just going to leave it at 0 because I'm going to show you guys what this is for. Actually, I'm going to use the LCM LoRa. So basically, these LCM models have been trained so they exist as LCM format. But you can take any existing model, excuse me, and turn it into LCM by using an LCM LoRa. So You could take any model you like. So if you like other models like realism or things like that, excuse me, realistic vision, things like that, you can run that, and then you can run an LCM, and that will make it generate much, much faster, like half the speed or half the time. All right, clip goes into the clip of the motion of the LoRa. We did this last week, so this is all pretty straightforward. So we have a KSampler. We have our VAE decoder. And then we have our save image, but we're not using save image for this. We're using a node called Video Combine. It's part of the Video Helper Suite add-on pack. You can get it in the manager. And this saves movies instead of images. So that's what we're going to use it for. We're going to set the frame rate to 24. We're going to use the AnimateDiff file name prefix. We're going to use MP4, CRF, this number, anywhere between maybe 10 and 20. The lower you go, the more high quality your video is, but the larger it is. Okay. Save metadata saves the patch in the video. So you can always just drag the video into Comfy later and rebuild your whole system. And save output decides whether it just shows you a preview or actually saves a file. Now you'll see I left a big blank space here, and there's a reason for that. So we need to add our positive and negative prompts. So let's add a prompt, clip text encode. Clip goes into that. We copy and paste, make a second one. Okay, that's our positive and that's our negative. So we'll make it green and red. All right. Actually going to put them down here so we can see a little better here. Maybe make them a little smaller because they don't need to be very big. All right. So there's a big empty space here. This will just make an image in its current format, this setup. Oh, I need to also set up the LCM stuff. LCM for AnimateDiff works best at 11 steps, 1 to 2 CFG. We use LCM sampler, and the schedule is SGM uniform. So those are the settings right there. I'll just leave that screen up for a few seconds. So if you ever need to just come back here and look at it real quick, this will be it. These settings will get you really decent results with LCM. All right. Big empty space here. That's because we need to add AnimateDiff. Manager, install custom nodes. You want to look up AnimateDiff and install AnimateDiff-Evolved. Okay. Download that. Restart Comfy. It will take a little while. And then when you come back, turn Comfy back on, load up your project again. It'll look like this. Then you'll have some new nodes in the node thing here. You're going to, just for this is a dead simple setup. So we're just going to use the legacy AnimateDiff loader. Okay. This is the original version of the AnimateDiff loader. We don't need all the fancy stuff in version 2 right now for this, so we're not going to bother. So this AnimateDiff loader, AnimateDiff animates AnimateDiff-Evolved animates chunks of animations. So this will animate 16 frame chunks, and then it'll take those chunks and it'll slide into the next chunk over time. So if you say your batch is 240 frames, that's 240 divided by 16. That's 15 context windows. So you would think of it as sort of 15 context windows as time's going by, and it's sort of interpolating between each one. So these settings here, let me set the LCM settings 1.15. There are a few things to plug into AnimateDiff to help us understand what's going on. First, you need a context options, and this is what the context window does. For this, we're going to make looped animations, but if you don't care about looping, you can use standard or static. Yeah, I just like looped. I like loops. They're great. So this is here. This is explaining, or this is showing us what our context length, stride, and overlap are. So the context length is how big the window is, and for AnimateDiff, it's 16 frames. The context stride is something I don't fully understand, so I kind of leave it alone. But some people say you get better results at 2 and 3 for certain things. I haven't really looked into it that much. As far as I understand it, it tries to skip a couple contexts to find one that's closer to the one that you were using, but I might be wrong about that. So yeah, take that with a grain of salt. And then context overlap is how many frames in between the context windows that it tries to sort of mix together or interpolate. So as it's moving from one to the next, the higher that number, the more the two will mix together. If it's really short, if your context overlap is like 1 or 2, there'll be like hard cuts as it jumps context windows. But the higher that number, the sort of more smooth the animation is. But too high and it takes too long to render, and it can look a little weird. So I like to keep it around 3 or 4, and 6 for batch interpolation, which we'll talk about later. To make a loop, I tend to make closed loop and use equal length, and then those are basically the settings for a looped animation. And then with AnimateDiff, I also like to add sample settings, and you just click the node at the bottom that comes up when you let go of the noodle here. AnimateDiff sample settings, and the noise type I like to use empty. And then one more thing for the AnimateDiff is custom motion LoRAs, AnimateDiff LoRA loader. So now so you can get these on Civitai, you can get them everywhere else. So I'm going to use Jeru's Shatter. This motion LoRA tends to make animations like this, so we'll try it out and see what we can get. Each motion LoRA has a particular style it's trained on, 16 frames of animation that it's trained on. I have a video on training custom motion LoRAs, and I'll talk about it later, but we don't need to do that now. You just need to know that motion LoRAs exist and you can use them, and they are trained on little chunks of animation, and they help guide the AnimateDiff animation towards that movement. So, got our little AnimateDiff stack all set up here. Let's move things around a bit. It might be easier to understand like this. Yeah. Okay. And I'll just make that nice and big so you guys can see the settings there. All right. This is like a dead simple setup for doing AnimateDiff stuff, and this is basically the core of any of your animation stuff. So yeah, learn this, learn what all these things mean and do. Model name beta schedule is the noise. It's kind of like a sampler, the way things are denoised. Excuse me. Motion scale is how much motion it tries to apply to this motion LoRA. And this, you want to always start at 0.5 for the motion LoRAs. When you go over that, then you start to reveal the training data and stuff. So, all right. Model goes through the AnimateDiff loader into the KSampler. So this will technically work as soon as I add a latent image, which we talked about last week. So empty latent image. This is where we set our resolution and how long our animation is. All right. So 512 by 512, 16 frame animation. Actually, let's make it a 24 frame animation so we can make sure that it loops. We're going to add NSFW and nude to the negative prompt, and to the positive prompt, we're going to add a beautiful flower blossoming in a gorgeous verdant green field. Okay. So, boo, boo, boo. Boo, boo, boo. All right. That should be the whole setup. Let's run it and see if I screwed up. I screwed up. So luckily Comfy tells you what you did wrong. In this case, I forgot to plug the VAE in. Try that again. Forgive my cough and voice today. I've gotten sick over the last few days, so I'm just trying to get rid of it. Hey, look at that. Looks pretty cool to me. All right. So that's with text. What if, just let me color these up so we can see what we're looking at here. All right, there we go. So what can we do from here? We can extend the length of the animation down here with the batch size. Do a 48 frame animation. If you're wondering how I'm triggering it, Control Enter will just do the thing. So start the queue. So you don't have to grab your mouse and reach over and go to queue prompt and all that. And if anybody has questions while we're going, please feel free to drop them, because now is the time to go through stuff. If you're not understanding it and I'm skipping by it, I want to cover it. So this animation should be twice as long as this one. One cool thing you can do if you want to sort of make a little gallery of stuff you've made so you can see it all at a glance is just copy and paste these video combine nodes before the next one fills out. And you can make like a little sort of gallery of stuff you've made at a glance, you know, till you run out of VRAM. Very cool. So we can use this to plumb the latent space to just find cool stuff and make cool animations out of it. But what's the next step? Prompt travel. So this is a single prompt, but those of us who came from Deforum schedule prompt schedule. I'll find it. Batch prompt schedule. Okay. This is part of the Fizz nodes group, the Fizz nodes add-on. This is a Deforum-like prompting system that we use to decide at what keyframe things happen. Okay. The best way to describe this is just to show you. Okay. We're going to keep our negative conditioning separate, and we're just going to use this for positive conditioning. So the clip goes through. Oh, it looks like I forgot to send the model through to the right place. Okay. Clip. Positive to positive. All right. So this is just replacing our positive prompt with one that can take multiple. Okay. So have a look at this structure here. Let me make it a little taller. Okay. This structure matters. If you don't do this correctly, it will fail. So quotes number, space, colon, quotes, prompt, comma, no comma on the final one. That's the syntax. So let's try a man walking through the forest. And then at frame 32, it'll change to a portrait of an old man standing in the forest. And then we'll make a 48 frame animation. So it'll start at frame 0. This will happen. And then at frame 32, it should transition to this. And then loop. And well, one thing we can do is then again at frame 40, we can put the first prompt in. And that'll sort of make it try to loop around to the front. So if you end with the prompt you started with, you know, you can basically make a loop. Assuming you're using the looped uniform context options. I'm actually going to turn this into a stack because it's triggering me. Oh, yeah, that's better. Okay. Right. So, man walking through the forest, a portrait of an old man standing in the forest, a man walking through the forest. So it should make a loop and it should jump between two contexts. Let's try it. And your little gallery will always complain when there's nothing plugged into it. Don't sweat it. It doesn't matter. It doesn't mean anything. It just means there's nothing plugged into it. So that on this run, it won't do anything, which is what we wanted anyway. Because we're just using this to preview previous runs. So there's a bunch of different ways to control composition. And after this run, we're going to try some of them. We're going to dig into ControlNet. We're going to dig into IP adapters. And we're going to dig into IPAdapter weighted batching, which is really fun. And then if I think of something else while we're going, we'll dive into that too. But basically, after you've done this video, you should be able to pretty effectively make animations on your own. At least to the point where we can start doing other stuff where you're following along. Okay, so all it did was flip them around for the portrait, which is, you know, it did something. Can't really complain. But yeah, it's pretty cool, you know. Except for the fact that it sort of flips around. You cannot schedule other parameters other than the prompt, unfortunately. That's what we're going to talk about with ControlNet and IP adapters masking and stuff like that. So one of the drawbacks of AnimateDiff is that these transitions take sort of the length of a context window to happen. So even if we were able to schedule other things like strengths and weights and stuff, it wouldn't take effect for, it would only take effect for each 16 frame batch, basically. So as a workaround, ControlNet and IP adapters are actually really fast at turning masks into stuff. So if you want to do like audio reactivity, you would make an audio reactive mask in something and then use that mask to drive your animation. We might do that very last at the very end of this if there's time. But I'll give you all the tools you basically need to get there anyway. I do have some other videos on that as well, so might not have to do that today, but I know people are excited about audio reactivity and it is cool, but it's a multi-step process with AnimateDiff. Excuse me. I need a cough button. Okay. That's the basics of prompt travel. The longer you go, the more cool stuff you can do. You can do really fun stuff where you walk through different cities or whatever, and it just automatically change and do cool stuff. But let's say instead of prompts, you want to drive this with images. So we covered this last week, actually, with IPAdapter. So I'm going to put just a static prompt back in here. Flip in, conditioning out. Okay. Green, red. So because we're using IP adapters, we don't need to do anything in the prompt, really. I'm just going to put 4K, high resolution. The IP adapter is going to do all the work here. Okay. So I'm trying to decide if I want to do it before or after AnimateDiff. Let's do it after. So just like last week, we're going to add a IPAdapter unified loader. We're going to set that to plus. And this is going through the model chain, okay? So model goes from load checkpoint, load LoRa, AnimateDiff loader, IPAdapter loader, IPAdapter nodes, KSampler. Just the purple chain just keeps going, And I'm going to use IPAdapter. I'm just going to use a super simple IPAdapter setup for our first test here. All right. I'll plug IPAdapter into IPAdapter, plug model in through. So this image, we need to feed it an image, but it's not ideal to give IPAdapter a ginormous image. So I'm going to add a thing called image upscale or image scale, upscale image. And I'm just going to tell it to upscale to 512 by 512 and crop it in the center so that whatever image I add, it's just going to crop the center and make it nice and small for IPAdapters to be able to see it. Should we do Ryan Gosling? Let's do a dumpster fire. Accurately sums up how today was going. Let's go you, and you. And blue. Okay. So let's run this stack one more time. We're doing the IPAdapter unified loader. So it's loading loading the IPAdapter models. We're feeding the models into the IPAdapter node. And then into the IPAdapter node, we're feeding in an image that has been cropped and resized to 512 by 512. All right. And hopefully this will just make a dumpster fire. Let's change it to 24 frames for a faster render. I'll get rid of this guy here and go. So like, as you can see, all these things are just modular, right? Like this is a stack. This is a stack. This is a stack. This is a stack. And output is a stack. So we can actually name these little groups and it'll help our brains a little bit here. So let's go settings and checkpoint. This one is AnimateDiff. This one is IPAdapters. And this one is diffusion. And this is our output. I mean, it's pretty accurate dumpster fire. Nailed it. So, we can do one image. Can we stack IPAdapters to do multiple images? Yes. Can we stack multiple images into the IPAdapter? Yes. Can we tell the IPAdapter what to look at in an image and only do stuff in that part of the image? Yes. Can we do multiple images that are just interpolating between each other over time? Yes. We can do all of that with IPAdapter. You don't have to touch anything else. So let's try all that stuff, okay? Except for the multiple embeds. I think we'll save that for another day. But we will do batched interpolation, which is really cool. So first things first, let's cover attention masking. We covered it with images a couple days ago, but this is how to do it with animations, all right? So let's move our stuff over and give our little IPAdapters bubble a little more room to play here. Okay. So we have our loader, and now we need another IPAdapter so that we can have two different things, okay? Same setup, IPAdapter goes through, model goes through the IPAdapters. So it starts here, goes through this one, into the KSampler. But right now I have two identical images. So let's find another image like this mall. Okay. Now, what do we think is going to happen here? We're probably going to get a dumpster fire that's mixed with a mall. Let's find out. Looks like now there's a dumpster on fire in a mall. the pace of this won't be as breakneck as the last one because animations take longer to render. Yeah, okay. The mall's on fire. The dumpster's on fire. They've been mixed in an interesting way. But what if we don't want the dumpster in the middle and the mall around it? Well, we're going to do what we did yesterday. We're going to open up a new tab. We're going to go to the Comfy URL. We're going to clear this workspace so we have a fresh workspace, and we're going to get a create shape mask. This is part of KJ nodes. If you don't have create shape mask, go install KJ nodes from the custom nodes. All right. Restart Comfy and come back. Square. So right now we're making a mask. I'll show you what I mean. Pop this little mask preview out. Boop. So this is making a little mask. So what we're going to do is draw the dumpster where the white is and draw the mall where the black is. But we want to increase the size of the dumpster a little bit. So I'm going to increase the shape, width, and height. That's a little too much. Let's try 320. Let's do 300. That feels right. Okay. So these are the settings I need to make the mask, okay? So let's copy this. Control C. Just paste it up here because we have our settings and it works. We know our empty latent image is 512 by 512, so that's what we're going to work with the mask. We're going to plug mask into the attention mask of the first IP adapter. Okay. And we're going to plug the inverted mask into the second one. So if we look at our mask, this is the mask part and this is the inverted part of the mask. So dumpster, mall. Okay. Let's try that. Lance asks, what is the maximum number of IP adapters you should use in a workflow? Your GPU will let you know when you've used too many. I think you can use quite a few. The issue is the more you do, dilutes kind of what you're trying to do. So you really want to use them effectively like this. Like, you see how when we mix the two, we kind of lost the cohesion of both things in the scene. The mall and the dumpster became one thing. Whereas when we mask it, now there's a dumpster in the middle of a mall, right? Because it's following this. Forgot to add a preview. Because it's following this mask, right? So that begs the question then. Does the mask need to be static? It does not. So we have a 24 frame animation here. Let's look at our mask again. So there's a cool function in the create shape mask tool called grow. Okay. Let's make our shape width 16 by 16. So it's just a little guy. And we're going to make it grow 10 pixels every frame. Oh, and we're also going to view this as a video. So right now it generated 1 frame, but we're making 24. So let's make 24 frames. And let's have a look at it. That's close, but it's not getting all the way to the other side. So let's try 20. It's pretty good. 24. 22. That's good. Okay. So just starting as a tiny dot and then moving its way out. All right. So what do you think is going to happen when I plug this mask in? What should happen is a dumpster should start in the center and just get bigger and bigger and bigger until the end of the animation. Let's see if that's the case. Now you can make these masks in anything you like to make masks in. I make my masks in Blender. You can make them in After Effects. You can make them in Magic Musical Visualizer. You can make them in GLSL. You can make them in Touch Designer. You can make them in Comfy if you want. There's some tools for making these masks in Comfy. It's not as comfortable as other methods, but it does work. We're doing it right now. I should have rendered a little video of that mask so you can see exactly what was happening there. Oh yeah, there it goes. See them? It's just kind of pulling out from the center because we're literally like making the dumpster context bigger over the course of the animation. Anyways, it starts as a mall and then turns into a dumpster. Very cool. So let's do this. Let's add a image to video or mask to image. Yeah. And then we'll add a little video combine here. Scooby Doop Doop. And we're 24 frames per second. MP4. And we're not going to save this output because this is just for us to visualize what's happening. In fact, I'm just going to add these to the other project because it'll click faster. So that's the mask we just generated. So that's what it was looking at when it was making this animation. Yeah, the context of the dumpster keeps sort of... So let's load a video. And I'll go to my mask collection. If I can find it. It was 2402 mask pack. And we'll go with a constant mask. Let me find a cool one. So these masks were just made in Blender. Actually, this one might be perfect. Is this a PNG sequence? It is. Okay. So I'm just grabbing the path to this PNG sequence. You can also load videos if you want, but I'm just going to load this via path. All right. So load video, path. Paste that path in. And if I'm right, let's do our testing in this window here so we don't have to do the whole diffusion run to find out if it works. And video combine. 24 MP4. Busy phone today. 24, 15, sure, save output off. So let's have a look at this video. Why you mad, bruh? Ah. If your path has spaces in it, you should add quotes around it. Oh, or not. Or maybe it can have spaces. Oh, I know what I did. This is the load video path. Load image path. What's going on here? Path. Load images path. There we go. Let's try this again. Oh, I closed the window. Oh, yeah, definitely. All right, let's try this one. This is going to work this time, I swear. What do you say, Bay? Okay, so let's try this loop. It is 64 frames, which is great because it'll loop after 64 frames. So let's try this. Okay. So let's think about this mask. It's already a mask, technically. So let's see what our mask output gives us. This might not work because mask means different things in different nodes. And I feel like in this case, the mask is going to be the alpha channel that doesn't exist. Hope we can find out very quickly. Let's add a preview here. See what it makes. Nothing. Okay, so this mask is referring to the alpha mask in the video, which doesn't exist. So we need to make a mask. Fortunately, this is extremely easy to do now. Image, search for RGB because we want mask from RGB CMYBW. Okay. All right. So this looks at the mask and then gives you a mask for each color in the mask. So I have a black mask and a white mask here, which will be my mask and my inverted mask. So where do those go? That's right. Into both of these nodes. Black goes in the first one, white goes in the second one, and that's essentially our inverted mask. You can see what this looks like by doing this. Mask to image. Not apply a mask to image, sorry, mask. That one. No, not that one. There's too many nodes. Convert mask to image. Okay. So let's plug the black and white masks in and then grab a couple of these. Actually, no, we'll do a concatenate. Let's get fancy. I'm only moving this stuff over to the other workflow so that I can run it without having to run the whole shebang every time. So now what this should do is take these two videos and put them side by side. And we should be able to see what the white mask is and what the black mask is. Okay. So those will be the two masks for the two IP adapters. So it's going to put on the left, it's going to put the stuff, in the white, and then on the right, it's going to put stuff in the white. So it'll mix the two together. So you can think of it that way. So let's set our frame rate. So here's the best way to deal with frames in videos. Okay. Once you have a video you're loading and you want to make it loop, you kind of need to use the frame count from the video as your length so that you don't have to think about it every single time. So this is popping out a 64 frame video. That's what this int is, this integer. In some of these nodes, it's called int. In other nodes, it's called frame count. But it's just how many frames there are. So all you do is go to your empty latent image. And you change, right-click on it, and convert widget to input. You want to get batch size, turn it into an input. And plug the int into it. Okay? So now, the length of our animation is determined by how many frames we're loading of a video. This is cool because if I want to make a video that's twice as fast for a shorter render, I just have to click this select every nth and spin it up one, and that'll make the video go twice as fast and make it a 32 frame video. 3 will be 3 times as fast, 4, etc., etc. Skip first frames is how you seek into a video to tell it where to start. And image load cap is how many frames of the video you want to load. You can get very surgical with this to get like exact clips out of your videos and stuff. Okay. Let's try 2 images that are just wildly different. Let's try watermelon and I don't know, fire. Do I have any fire? Let's try fire and water. Okay. So hopefully we'll get a mix of fire and water. This is looking cool already. Did I miss the video where you create these black and white masks? Yeah, it was actually quite a while ago. I've done it a few times. Whenever we're rendering stuff, I'll just jump into Blender and start making masks. But yeah, I will make a dedicated mask tutorial for Blender very soon. For constant masks, depth maps, things like that. Basic shader tools, basic shader math, basic texture math. All the tools you'll need to make your own masks. But also, there's a million of those tutorials also all out there already. Check out Ducky 3D. Check out Default Cube. Check out Curtis Holt. Check out who else? Charon. I'm blanking on his YouTube channel name right now. Ooh, very cool. So that is one way of controlling composition using IP adapters, and this can be extended. It doesn't just need to be black and white. How would we extend it to more colors? Model to model, model to model, IP adapter to IP adapter. Or fire, water, and I don't know, Mr. Bean. Perfect. So we have this mask and it's 2 colors. But what if we had a mask that's 3 colors? Let me find one. Okay. Let's try this one. So this mask, the red, the green, and the blue will be 3 different masks. Actually, maybe this one's better. Yeah, let's try this one. So we're going to copy path. I'm just going to delete this node. And I'm going to use load video path. Paste that path in, remove the quotes, I think. Force the rate to 24 frames per second. The image goes into images. Image goes into this mask thing. And now we're not using black and white anymore. We are using red, green, and blue. So we need one more of these. All right. And then red, green, blue. Red, green, blue. Okay. I think that should do it. So we're loading an RGB video. Sorry, I lost my train of thought there. ADD baby. All right. RGB video. We are pulling out the red, green, and blue. We're going to make a mask so you can see them. Those masks are fed into all 3 IP adapters, and we're going to alternate between water, fire, and Mr. Bean. As one does. Yeah, that should do it. So it's loading the video now. Oh, you know what? I didn't check how long that video is. It's 140 frames. So what I'm actually going to do is I'm going to go cancel this job. And I'm going to do that thing I was saying before where I speed the mask up to make it go faster. So I'm going to speed it up like 3 times. So it'll be 140 divided by 3, 45 frames, 46, 47 frames. I can math. So there's our 3 masks, and these 3 contexts should now intersect in these, sort of timings. This can be extended for as many colors as you want. You don't actually have to use this node. There's another node called mask to color where you can select the color values. So the sky's the limit here color-wise and how much, you want to go crazy with this. Did I screw something up here? Does it think that's the same? Oh, yes. Thankfully, Comfy tells us where we screwed up. Where did I screw up? Forgot to take the frame count from the video editor to the video loader I changed. And plug that into our batch size. So, boop, there we go. That should work. I just hope Mr. Bean pops out every now and then. I guess we all wish that. Hey, nice. What's up, Mr. Bean? So yeah, these workflows are on my Discord for free. Go grab them. Go play with them. This one's called context smashing. Excuse me. It's also available on Banadoko. There's a RGB version and an RGB CMY version where we go red, green, blue, cyan, magenta, yellow. And yeah, I uploaded a bunch of masks and stuff so you can get started without having to make your own masks. But let's say you wanted to do this. You wanted to jump contexts, but you don't want to mask it. You don't want to worry about the actual composition. You just want them to interpolate between each other over time. Thankfully, Cubic Mateo has made this very easy to do. So I'm going to actually delete most of this stuff. So we're going to start fresh here. We've got our IPAdapter model loader. We are going to do something called IPAdapter Weights. This is new. This is fun. This is awesome. All right. IPAdapter Weights is going to interpolate between images and then feed those images to two different IPAdapters nodes at different intervals. And it's going to allow it to sort of shift through them over time. So let's set this to 0.66. Now what this is the maximum and minimum of how hard the IPAdapters kick on. So we're only going to let it kick on about 66% and let the prompt also do some work. Actually, maybe we'll go with like 75%. Yeah. The timing we're going to leave on linear. The frames is the amount of frames each image hangs out on the screen. So for now, we're just going to set that to 12. And add starting frames and add ending frames. This helps with the beginning and end of the batch to make it work pretty good. So these would be the settings I would kind of start with. You can start with a lower frame count. This frame count determines how long your animation is, because as you know, it's going to sit on each image for this many frames. So I'm going to do 12 to try to maintain the sort of coherence. And another thing you want to do is start with a context overlap of 6 for this. Okay. So this works a lot like the other IPAdapters nodes, except this one feeds weights into. We need IPAdapter advanced batch advanced. IPAdapter batch advanced. We need 2 of these nodes. Okay. Model goes through out to the KSampler. So instead of loading an image into each of these, like automatically, we're going to do it with this. Image 1 goes into here. Image 2 goes into here. And we're going to change weight to an input on both of them. All right. We're going to take our weights and plug them into weight. And plug our IPAdapter model into each one. Very cool. Sorry, weights goes into the first one. Weights invert goes into the second one. Total frames, you guessed it, goes into our batch size. Right? Okay. Now we need some images. So we need an image batch. I like this image batch manager by SuperBeasts AI. It's in the SuperBeast pack. I like it for reasons that I will very quickly explain. Let's load an image. Oh God, I got too many images. Too many images. Let's start with fire. Right, and then image 2. We'll do... Let's try some whitewater rapids. There we go. All right. So here's what I like about the node. I want this to loop, so I need it to actually land back on image 1. Normally what I would do with an image batch is plug 1 into 1, 2 into 2, 2 into 3, and then 1 into 4. So it would go 1, 2, 2, 1, and then loop back on itself. But SuperBeasts made this cool thing where I can go 1, 2, 2, 1. And if I'm correct, this should make an image batch. I'm actually going to make a preview so I can make sure that that's correct. Okay. I actually think that's all set up and should just work. All right, we're going to YOLO this or what? We don't need these anymore. Or this. Hey, look at our batch. 1, 2, 2, 1. Hey. Excuse me. Sorry, everybody. Excuse me. So yeah, I mean, we've done a lot of stuff here and we haven't even touched ControlNet yet. There we go. So as you can see, this is a really powerful way to take stuff that you've already made, stuff you've generated, stuff you make, mix it together, and yeah, very cool. So of course this is extendable, right? Let's try some Sweet Baby Ray's and I don't know, Ryan Gosling. Sure. Let's get rid of this. And your image 3 and your image 4. So we're going to go 1, 2, 1, 2, 3, 4, 1. So now we should go fire, water, sauce, Gosling, fire. Ideally. Ryan Sosling. Yep. One really cool way to use this is to set up another tab where you make SDXL images. Make like a batch of like 8 images, and then you can just kind of just interpolate between them. 1, 2, 3, 4, 5, 6, 7, 8, 1. Camera really likes to track my mug. It thinks it's my head. Do I have a mug head? Maybe. So if you increase this value here, the number of frames, it'll sit on each image longer. But you can also do that by adding it again in the list here. So like 1, 2, 2, 3, 3, 4, 4, 5, 5, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1 will be like 1, 2, 2, 3, 3, 4, 5, 5, 1, 1. So it'll like, yeah, just double them up and make sure it just loops back on itself. If you want to loop, if you don't want to loop, it doesn't matter. You can just interpolate between however many images you like. And this is a really cool way to extend this workflow like way out. You could do 16. You could do a whole storyboard if you really wanted to. Not bad. Fire, water, sauce, Gosling, fire, water, sauce, Gosling, fire, water, sauce, Gosling. Doesn't look like Ryan Gosling at all, but you know, whatever. All right. So that's IPAdapter's batches, weighted batches. Let's delete all this and go back to basics. Oh, I deleted AnimateDiff. Let's rebuild that real quick, see if you guys can remember. Unified loader. No, AnimateDiff. Legacy. Let's see if I can remember. Text to video, LCM, square root linear, 1.15. Let's add looped context options. 16.14 is fine for what we're doing here. Boop, boop. And I also need sample settings. I'm going to set those to empty noise. Yeah. And we're just going to add a motion LoRa. We'll go back to shatter. Okay. Model. So our IP adapters is gone. Let's rebuild it. Hey, deep surface. All right. IP adapter. We're just going to use a dead simple one here. Because words. Because we're going to be using ControlNet. IP adapter. We only need a little bit of guidance here. So let's add an image. Let's do the dumpster fire, I guess. Okay. IP adapter in, model to model. Okay. Okay. So ControlNet lives on the conditioning chain. So ControlNet is used to guide things towards a specific result, depth map, line art, whatever you want. There's a million ControlNets. Go look up ControlNet. Go look up all the different kinds. There's even some specific to this process, like AnimateDiff ControlNet, ControlGIF ControlNet, box control ControlNet, loose control ControlNet. I'm not going to cover them all tonight. It's too many. But I'm going to show you how to pre-process some footage and use it. All right. So most ControlNet footage needs to be pre-processed before you use it, unless you're actually making depth maps or line art or OpenPose. There are methods of doing that, but you know, whatever. We're just going to start with having footage and then making things happen with it. So let's grab load video. And I'm just going to grab a video of a dancer that I have here. Okay. So you'll notice the beginning of this video, he's not moving, and then he starts moving later. So we want to actually start this video a little later than normal. So we're going to skip the first like 140 frames. We're going to force a frame rate of 24 frames per second. We're going to make it 512 by 512. You don't have to do this in this node. You can do that with that image scale thing I showed you before, but you know, whatever. Frame load cap. This is what we're going to do. We're actually going to set it to 64. So it's only going to load 64 frames because that's, you know, we don't want to make a big long animation to test this. We just want to try it out. You guessed it, frame count in a batch size. Okay. We need to apply ControlNet Advanced. All right. And we need an advanced ControlNet loader. We're going to use depth. You get the ControlNet stuff from install custom nodes, get the models from models, type in ControlNet and get all the ControlNets you want. So you can plug this right in, but what will happen is it'll look at that image and then it'll try to look at it as a depth map and it won't work. So we need to actually pre-process this footage into a depth map. Okay. So we're going to use depth anything. So our images are coming from the load video into depth anything. Feed them into the image of the ControlNet. Feed the loader into the ControlNet, and then just pass the positive and negative through ControlNet. Positive, negative, positive, negative. Okay. IPAdapter and AnimateDiff, they live on the model chain. ControlNet lives on the conditioning chain. Yellow. And the other thing we're going to do is we're going to pop a video combine out of the depth anything so we can actually preview what our depth map looks like. Okay. Okay. What do we think is going to happen here? It's going to make a depth map of this person, and then it's going to try to turn them into a dumpster of some kind. I don't know what's going to happen, but let's hit it. So now it's loading up the video. It's skipping 140 frames into the video. It's loading 64 frames into the depth anything preprocessor. Excuse me. It's now making a depth map of this dancer. Excuse me. Just trying not to die. So there's our depth map. I had the wrong IP adapter loaded. I've been using Plus for these. You can try the different IP adapter models. So you notice our strength. Excuse me. Our strengths on IPAdapter and ControlNet are full out at 100%, one here. So it is doing as much as it can here. So you can back off both of these, the weights and the strengths, to like get different effects. Highly recommend you play with that with really short clips and see what it does. Minimum amount of frames you can do for an AnimateDiff animation is 16 frames. So if you do more than 16 frames, you'll get to see how the animation reacts as it strides a context window. If you only do 16 frames, you won't really know what the animation is going to look like because it doesn't get a chance to jump out of that first context window. And yeah, I recommend doing short run until you really like what you got, then do the long run. There's no point in doing long runs over and over and over again if you're not sure about the results. Perfect. So yeah, you see it's mapping everything to the depth map, and it's turned it into a dumpster fire. That's exactly what I asked for. So I'll just talk about a few different kinds of ControlNet and how you can stack them. Just grab the whole stack, pass the positive and negative through. We're going to try a DWPose. Image goes in, through to ControlNet, through to the video combine. Okay. Now I'm going to turn the depth ControlNet off so we can see what this one is doing on its own. And I'm actually going to reduce the frame cap to 24 so that it's a much shorter animation. So currently the only ControlNet that is active is the DWPose. And every time you add a ControlNet, I recommend you actually disable the other ones so you can get a feel for what each one is bringing to the final result. You might find you don't actually need certain ones. So, yeah. So this one is called DWPose, and it goes through and makes a little skeleton of the person, like a motion capture of what a person does. Only works with people. There's a animal version that works with like 4-legged animals and stuff, but I haven't tried it yet. Looks cool. So if you have a video of a giraffe dancing or something, I guess you could AnimateDiff it. Yeah, there's our little guy. So now it's just going to use this and ControlNet to try to make this happen, but without the depth map. So I think what you'll notice in this is we'll lose all this information here. The pillar, see how the pillar's there? You got some of this stuff going on. We're going to lose a lot of that in this animation because all we have is the person. Oh, you know what's funny too? I forgot to change this to the DWPose ControlNet. So it's actually doing a depth map run on this. So this is actually good because I can show you what happens when you run the wrong thing through the right ControlNet. Yeah, see? So that happened because I looked at this with depth ControlNet. I want to look at it with OpenPose ControlNet. Let's try that again. As they say in Rocket League, calculated. That looks more like a human person. I do like this little skeleton guy, though. Whoop. Whoa. I like that he kind of merges with the dumpster, too. That's neat. Yeah. Nice. So, yeah, DWPose is really good at capturing the person's movements and stuff. So you start combining them and you can get really cool stuff. Let's try one more. My favorite stack for doing stuff like this is actually 4 ControlNets. So let's add them. I like to add Lineart and Soft Edge as well. Lineart, Soft Edge. replace these preprocessors with the Lineart preprocessor. There's actually a new Lineart preprocessor today I got to check out. It just came out today. In soft edge. HED soft edge lines. Okay. Same deal. Image in. Image in. Image out. Image out. And also pop one into each preview. And the last thing we have to do is pipe that positive and negative prompt through all this stuff. So now your positive and negative chain should go through all 4 ControlNet nodes. All right, so let's turn this one off. Let's turn this one off, and we'll just start with Lineart. Lineart, soft edge, DWPose, OpenPose, depth, anything, depth. You always want to double check that you're running the right preprocessors and models. All right, so right now, Lineart is the only one that's activated. So let's hit it. So Lineart's going to give us this, and soft edge is going to give us bigger, more outliney edges. Should talk about start and end % while we're here. So the strength is how much ControlNet tries to take over from the whole run. But this start and end % is actually how to tell Comfy when to engage and when to disengage ControlNet during the run. So this is not based on the amount of frames in the run. It's based on the overall steps in the run. So what I like to do is back off the start % by about like 1 or 1.15, 0.1.15. And what that does is it lets the dream start to happen first. Then the ControlNet kicks on 15% of the way into the run. And then we end it around 75%. And what that does is it only makes ControlNet lock on in the middle of the run, and it gives the beginning and the end a little time to coalesce and do a dream. Then we're just going to set all these to 0.6. All right. And so, oh, yeah, see the line art really captures the original stuff in the image. And the soft edge is really going to catch the edges. So yeah, try all these ControlNets, try out how they work, try out what they do, and make sure you're setting your strengths for each run so that you actively understand what each one's doing. But now I'm going to run one with all 4 ControlNets and see what it do. So they're all at about 60% strength, and they all start 15% of the way in and end 75% of the way in. So you'll notice it'll start with a dumpster fire because it's starting here in the dream. Then it's going to start putting a person in there. And then when it gets to about 75% of the way through the run, it's just going to let it dream wildly to get that last bit of detail in there. At this point, we're basically just recreating the input footage with some fire on it. And that's why it's important to play with all these settings and try to get a feel for it, for what they're doing. But ControlNet is by far the least latent way, the fastest way to tell AnimateDiff when motion is happening. That's why it works for this kind of stuff, because like, yeah, there we go. That's pretty damn good. So yeah, you'll learn what each one does and how it affects it and when to back them off and stuff like that. That being said, we have these ControlNets. We have IPAdapters. Is it possible to mask the person out, the floor, and the background, give it 3 different contexts for those things, as well as this information? Yes. Let's do it, you friggin' nerds. All right. Thanks to everybody who's been around this long. This is insane. Congratulations. This is heavy, annoying, crazy stuff to be going through beginner-wise, but I appreciate everybody who's hanging out and sticking through it. This stuff will help your animations like crazy if you're into this stuff. So yeah, I'm glad you're here. Thanks for hanging out. Let's keep going. All right. So I said a lot of things. First things first, I want to rotoscope this, right? I don't want to do it in After Effects because After Effects is expensive. And we have AI. So let's grab this little guy and we're going to take it over to the our little test window here. Oh, paste. Excuse me, sir. This is a Wendy's. All right, paste. All right. We have 24 frames, so we want to mask them frames. We need BiRefNet segmentation, but BiRefNet segmentation does not work in batches. It works in image lists. Okay. So we can't just plug this in and have it work because this is a list, not a batch. And there's no indication that that's the case. I just learned this by trial and error. So we need a batch to, to list, image list, image batch to image list node. Okay. All right. And then this goes in here. And then it'll segment our little dude here. And it's going to spit out a list of masks. So we need to make a batch mask list to masks. And then mask to image. And preview. I'm using a preview. You'll see why in a second. I'll explain why in a second. So yeah, I know this is kind of confusing and it seems like a lot of extra steps, but it is worth it. That is a pretty good rotoscope for free. So now we have two things. We have the person and we have the background. What can we do with that person in background? Well, what if we take that little node that we had before, right? Mask to RGB or RGB, what's it called? Mask from RGB. I guess I got to turn you into an image first. Oh, no, you're already a mask. I think this will get away with this. Okay, so this is a little confusing and actually confuses me sometimes. So we're going to work through this together. But we're taking our thing and we're getting our mask out. But I want to actually apply this mask to the original video. Let me think of the smartest way to do this first. We're going to actually do a little bit of compositing here, okay? So this is maybe a little more advanced than I was expecting to get into, but it's actually kind of really important stuff to understand in Comfy. So, okay, we're going to create two shape masks. We're actually going to make a shape mask because it's inverted. It's going to be a square. It's going to be 512 by 512, but the width will be 512. The height will be, I don't know, 200. And the Y will be about 300. Now what this should give us let's try it. Close. But I actually want to make this the ground, so it needs to go down more. So let's try 400. 420. It's always a magic number. Okay. So now imagine this is the ground, this is the background, and this is the dancer in the middle. How am I going to get the dancer in the middle? I need to composite all this stuff together. Okay. First things first, this mask needs to be red, this needs to be green, and the dancer needs to be blue. We can do that relatively easily. We're going to turn this shape mask frames into an input and grab the frame count. Okay. So we have a mask list the length of our other mask list. And I need to put this mask on top of these two. So, what's the not dumb way to do this? So we need an image blank. Now an image blank is just a blank image of whatever color you asked for. So I'm going to make a red one. All right. I'm going to make a green one. And I'm going to make a blue one. Okay. So, excuse me. I have the color and I have the mask. I need to combine these. I need to multiply these. Now I have to find the right image blend node. Ah, good. It's this one. Multiply by 1. Okay. I need 3 of these. And you guessed it. Image 1, image 2. Image 1, image 2, image 1, image 2. Let's see how bad I broke this. YOLO? Close. Okay. Oh, we didn't plug in image 2. We didn't, as if. Okay, there we go. So now my floor is red, my background's green, and my dancer's blue. So what can we do with this? IPAdapter stuff is what we can do with this. Now I want to combine these 3 into an image. So we're going to image blend these 2 together. So if I'm right, this image blend should make a red and green. It's not red. Is it multiply? Screen? Just got to find the right blend mode here. I think it's screen. Yeah, that'll work. Okay. So now we have our combined image, and we need to put this one on top. So we need to convert masks. No, convert mask to image. It's apply mask to image. Is it? No, there's another one. It's like combine mask. Oh, I can't remember the name. Image mask. I'll find it. Mask. Mask composite? No. Mask. It's something like that. Just go through every damn mask node. It's just a very specific node that gives me a source and a destination and a mask. It's not that one, is it? No. No. Is it blend by mask? No, that won't work either. Is it this one? No. We're so close. I feel like it was composite. You know, I have it in another workflow. Let's find it. It's in, where's my little dancer? There you are. It is the is it not this one? Oh, here it is. BiRef. Image composite masked. Okay. Image composite masked. So it's got a destination, a source, and a mask. That's what I wanted. Okay. Dumb. So my mask is the dancer. My source is the dancer. And this is the destination, I believe. Might be backwards. I always get those backwards. No, we did it. Okay. Well, that was a long run. But yes. So now we have this little thing, which when you have something like this and you're going to use it again and again, you can save it as a node template, and then you can just drop it whenever you want it, kind of thing. But this gives us what we need to do the IPAdapter nonsense I was talking about. So let's grab this whole shebang, and we're going to replace all this stuff with it. Actually, I'm just going to replace all this stuff with it. Okay. We have this final thing here. So we can split this into 3 masks for IP adapters. There's never enough room. Okay. So this final one here, we're going to use the mask from RGB thing. Now we have, excuse me, now we have our red, green, and blue. And where do those go? Of course, they go into the 3 attention masks down below. Red, green, and blue. So this is our floor, this is our background, and this is our person. So let's do like a marble floor. That might be good for a background floor. Let's do the background, which will be a, I don't know, baseball game. Copy. And the person, let's make them Dwayne Johnson. This probably won't work, but it'll be fun to try. IPAdapter goes into all 3. Model through. Okay. Just going over everything. Okay, so let's add these. Excusez-moi. Excuse me. Okay, this workflow has gotten a little crazy, but if I did this right, Dwayne the Rock Johnson should be dancing at a baseball game with a marble floor. Woo! It's funny how quickly these beginner tutorials expand. When creating shape mask, missing one positional argument frames. Ah, yes. Forgot to plug frame count into the frames. That should do it. Whoa, why are you so fast? Ah, you're at 67 frames. There's still lots of the background in because of ControlNet. So when you have stuff like this, you can back off ControlNet a bit. You know, each thing takes a certain amount of the sort of context. So you're contributing to a final animation. So sometimes if you back stuff off a little bit, it works better than just running everything at full. Not bad. Floor is kind of marble. I don't see the baseball game, but that's okay. I bet if I turned off all the control nets and we just let the IP adapters do everything, it'll look a lot more like a baseball game and a marble floor. So yeah, today we have covered basic animation, prompt travel, IP adapters, IP adapter batching, IP adapter masking, IP adapter weighted IP adapters. ControlNet. We covered depth ControlNet. We covered OpenPose ControlNet. We covered Lineart ControlNet. We covered soft edge ControlNet. There's more ControlNets. Go nuts. Go look at all the ControlNets. Try them out. We lost our boy, but it's definitely a baseball game with a reflective floor, so that's kind of cool. One other thing you can do when you're doing these animations is all we did here was mask out what's going to happen, but it doesn't understand that there's a person in there because it's just a mask. So instead of feeding it an empty latent image, we can actually feed it the input footage. And you do that by changing this latent image input to an empty or a VAE encoder. Right. And then we just plug the input footage. Whoa. Input footage into there. And our VAE into there. All right. And then latent. Okay. So now we're going to, instead of using empty noise for each frame, we're going to use the input footage. I don't know what this is going to do, but let's find out. Looks like we lost our boy. I'm starting to wonder if this one isn't working. We can check this by looking at these mask outputs and seeing what we got. Mask to image. It's possible they're broken. Yeah, it seems to be completely losing him, so I'm starting to think this blue is not coming through, but let's find out. Oh, no, it's working. Just really needs that ControlNet to get the body in there, it looks like. But yeah, that's our final composited mask there. So it's, you know, it's leaving room for this person, leaving room for the person in the bottom, putting the person in. You can also do stuff like this to mask the person out of the clip and then run them through ControlNet to cut out the background, things like that. So, yeah. I just don't see the dancer anywhere. Let's put the depth back on. Actually, no, just OpenPose. Let's put just OpenPose on. I feel like just OpenPose with the IPAdapter stuff should be fine. And the rock's back, although he doesn't look like the rock. But yeah, as you can imagine, sky's the limit here. Go insane. More resolution takes longer, but looks better to a point. Yeah, I think I covered everything I want to cover as far as like a basic animation course today. We actually went a little further than basic, but hopefully there's enough information in this stream to get you kicking. Between this and the stream before, if anything here doesn't make sense, go back one stream. I go through the dead basics of everything. So today was just an extension of that. If anything was crazy confusing, just hit up the one before. And yeah, all this workflow in various formats is all available on my Discord. Go over and grab it, have some fun. Hit up the Patreon, hit up the Discord. Can they be stitched together? Can what be stitched together? Yeah. All that. Thanks for hanging out, everybody. I appreciate it. This stuff's dense and kind of boring, and if you already know it, I understand these can be boring because, you know, like yeah, you just do that in an editor. Just do that in like Resolve or something. You don't have to do that in Comfy. I mean, you can, you just don't have to. Comfy's not good at processing stuff like that in the sense that video editors are made for it, you know? So yeah, hit up the Patreon, hit up the Discord, pick up the workflows. Workflows are on Banadoko as well. Next things I have coming up. Oh, I'll be on the Civit AI stream on May 24th, I believe. That'll be fun. I'll be hanging out with JBoog and we'll be making some crazy stuff. I'm not actually sure what we're going to do yet, but I figure something crazy will come out that week and we'll just cover it. Feeling that, I kind of want to get into the spline control stuff, so we'll probably dig into that next stream. Anyway, this sort of concludes the beginner streams for now. I might do another beginner stream if something comes up in my brain, but for now, I think those two are good bookends for, images and animation. And yeah, if you need more help, if things don't make sense, come to the Discord and post in the help channel. Post a screenshot of your problem, post a screenshot of your workflow. Give us as much information as you can, because just saying it doesn't work doesn't help us. It's just a mystery. So error message, workflow, image, any relevant information that can help us figure out what's wrong with your Comfy. Yeah, there's a million things that can be wrong, so we need a little more information to get it most of the time. So yeah, thanks everybody. We'll see you really soon. I think I'll be back on, what's today? Thursday. I think I'll be back on Saturday, depending on my throat. Feeling kind of talking is not comfortable. So yeah, we'll see how I feel. But yeah, I love everybody. Thanks for hanging out, and we'll see you really soon. Thanks everybody. Enjoy Comfy.